Hello friends, today we are going to discuss chapter number 7 alternating current, and only those previous questions will be discussed in this session, and we will start that from 2017 question. A series LCR circuit is connected to a DC source. The magnitude of inductive reactance is a diamagnetic material. It's Misner's effect. Okay, and the question is the same here. At resonance in an LCR circuit, the EMF and current are in same phase, outer phase, having a phase difference of pi by 2, having a phase difference of pi by 6. Just at resonance in an LCR circuit, the EMF and current, you have to write that in the comment box, okay? Then, you know what is the SI unit of inductive reactance? It's ohm. It's simply ohm itself. Okay. 2016 question. The core of a transformer has the following property. The core is laminated. Hysteresis low is narrow. Explain the significance of each property. And what is meant by resonance in an LCR circuit? And you know what is the significance of each property? It reduces eddy current loss and it reduces hysteresis loss. The core is laminated, it is used in eddy current loss, and hysteresis loss is narrow to reduce hysteresis loss. And what is meant by resonance in an LCR circuit? When the impedance of the LCR circuit become minimum. When the impedance of the LCR circuit become minimum, hence the current become maximum. This phenomenon is called resonance. The frequency of the applied signal at which the impedance of LCR circuit is minimum and the current become maximum is called resonance property. Frequency. So, what is meant by resonance in an LCR circuit? When the impedance of an LCR circuit become minimum, hence the current become maximum, and this phenomenon is called resonance. The frequency of the applied signal at which the impedance of an LCR circuit is minimum and the current become maximum is called resonance frequency. And later, okay, big question. The transformer either increases or decreases AC voltage. State the principle of a transformer. It's mutual induction. Whenever a flux linked with the first coil changes, an EMF is produced in the second coil. And this phenomenon, production of EMF in the second coil due to change in flux in first coil, is called mutual induction. Whenever a flux linked with first coil changes, an EMF is induced in the second coil. The phenomena of production of EMF in the second coil due to the change in the flux in the first coil is called mutual induction. The transformer consists of two insulated coils wound over a core. The coil to which energy is given is called primary, and that from which energy is taken is called secondary. The transformer consists of two insulated coils wound over a core. The core to which energy is given is called primary, and that from which energy is taken is called secondary. Working and briefly, with the help of a label diagram, the working of a transformer. The working and mathematical expression, let V1 N1 be the voltage and number of turns in the primary, and let V2, N2 be voltage and number of turns in the secondary. When AC is passed, a change in magnetic flux is produced in the primary. The magnetic flux passes through secondary coil. So the working and the mathematical expression. So here we have V1 and N1, and V1 represent the voltage and N1 represent the number of turns in the primary, and V2 and N2 represent voltage and number of turns in the secondary. When AC is passed, a change in magnetic flux is produced in the primary. Then the magnetic flux passes through secondary. If phi 1 and phi 2 are the magnetic flux of primary and secondary, we can write phi 1 directly proportional to N1 and phi 2 directly proportional to N2, dividing phi 1 and phi 2. Okay. Briefly explain any three energy losses in a transformer. Joules. First is Joules loss or copper loss. Then second is eddy currents loss. Third is hysteresis loss. Joules loss or copper loss: when current passes through a coil, heat is produced. When current passes through a coil, heat is produced, and this energy loss is called a Joules law. It can be minimized by using thick wires. When current passes through a coil, heat is produced, then the energy loss is called the Joules law, which can be minimized by using thick wire. Eddy currents loss can be minimized by using laminated cores. The laminated core increases the resistance of the coil, thus eddy's current decreases. What? Can be minimized by using laminated core. Laminated core increases the resistance. Hysteresis law: when an iron core undergo cycles of magnetization and demagnetization, energy is lost, and this loss is called hysteresis law, and this can be minimized by using soft iron core. When an iron core undergo magnetization and demagnetization, the energy is lost, and the lost energy is called hysteresis loss, which can be minimized by using soft iron core. We usually tune the radio to hear a program clearly. By tuning, what we are doing actually. When we tune a radio circuit, we adjust the value of L or C till we get, it's not there. Okay, we adjust the value of L and C. What are the essential components in tuning circuit? Resistor, capacitor and inductor. What phenomena can be observed in the tuned circuit? We can get maximum current of resonance frequency. The resonance takes place. What are the essential components? That is resistor, capacitor and inductor. How does it happen? When the impedance of LCR circuit become minimum, hence current become maximum. The phenomena is called resonance. The frequency of the applied signal to which impedance of LCR circuit is minimum and the current become maximum is called resonance frequency. Thus, the phenomenon is called resonance. The frequency of the applied signal in which the impedance of LCR circuit is maximum. LCR circuit should be minimum, okay, minimum, and the current should be maximum. Then, an AC generator is used to convert mechanical energy into electrical energy. But what does a transformer do? It changes the voltage level. What are the different types of transformers? Step up transformer and step down transformer. If I is an angular frequency of AC, then the reactance offered by L and C are respectively XL is equal to L omega and XC represent 1 by C omega. And an electrical bulb B and a parallel plate capacitor C are connected in series in an AC means as shown in the given figure. The bulb glows with some brightness. The bulb glows more because in introducing and dielectric slab the capacitor increases and hence the capacitive reactance decreases. Okay, so the current experiences less opposition which makes the bulb glow more. Yeah, so I think you have learned many questions, so that if you want you can go through all these things once more. So thank you, have a nice day.